For this question, we need to use the periodic table to determine a specific element that is an alkaline earth metal located in period 3 of the periodic table. So we know in the periodic table, the first column is alkali metals, but the second column is alkaline earth metals. And then each row of the periodic table represents an energy level. So period 3 alkaline earth metal is magnesium. So our final answer is D. We can use the periodic table to determine the number of valence electrons for each element using the number for the column. So we can see 1, 2, 3, 4, 5, 6, 7, 8. And here we're not including the transition metals. So we can go through and highlight each option. So for aluminum, we can see yes, it is 3. For bromine, yes, it is 7. For sulfur, we have 6, and so we know that our final answer is C. This question wants us to identify conjugate acid-base pairs, and it gives us an equation. So first we can go through and identify which is the acid, which is the base, etc. So we know that HF is a weak acid, so then H2O must be acting as a base. And now we can see kind of similar looking compounds as a reactant and a product, and these match up with each other. So the HF with the F minus and the H2O with the H3O plus. So since HF is the acid, F minus must be its conjugate base, and then H3O plus must be the conjugate acid of the base. So our final answer is C. For this problem, we're asked to determine the frequency of light given its wavelength and the speed of light. So the formula we'll be using for this is frequency equals speed of light over wavelength. So we know that the speed of light is 3 times 10 to the 10th centimeters per second. And it's useful to have the speed of light in terms of centimeters because our wavelength is given in centimeters. So we can just cancel those units pretty easily. And then our given wavelength is 4.50 times 10 to the negative 6 centimeters. So our centimeters, of course, cancel, and we're given units of inverse seconds, which is also equal to 1 over seconds. And our final answer is 6.67 times 10 to the 15th. So our final answer is E. This question wants us to find the general formula for non-cyclic alkenes. So to get some clues about what structure we need to draw, we know that an alkene contains a double bond between 2 carbon atoms, and non-cyclic means it will be what's called a straight chain alkene. So when you think about like a cyclohexene, it will not have the cyclo prefix, so only straight chain alkenes. So let's draw an example. So I'll just draw in this alkene, and it contains 1, 2, 3 carbons. So the beginning of our formula will be C3. So N is equal to 3. And then let's draw in our hydrogen atoms for this structure. So we have 1, 2, 3, 4, 5, 6. So C3H6. And if we need to draw this using the N formula, we do CNH, and then we see that if N is equal to 3, and we need something N in the formula, then we know that 6 is 2 times 3, so it'll be H2N. So our final answer is B. Let's use the periodic table to determine if these ions have a noble gas electron configuration. So for sulfur, 2 minus, it will be equivalent to argon, so that is correct. Ba plus will be equivalent to cesium, and so our final answer is B.